You said slide what? What else would I say?
Slide number 28, ladies and gentlemen. Okay, this part is not on there. You may want to copy it down and put it on there for yourself, ladies and gentlemen. Molarity is concentration. Okay, that is another way of saying molarity. You could say single replacement. You could say single displacement. They mean the same thing. You could say a limiting reactant. You could say a limiting reagent. They mean the same thing. You could say molarity or you could say concentration. They mean the same thing, ladies and gentlemen. Another way of expressing concentration is if you put brackets around an ion, that is read as the concentration of that ion or the concentration of that substance. So it's another way you may see things expressed, ladies and gentlemen. For molarity or concentration, substances must be dissolved in water, which means, ladies and gentlemen, they are aqueous, which also means they are a solution. Okay? And, I guess we could add this on there too. A solution. What? No, but I'm telling you this because it's some of the language in the problems that I've been giving you, and I just want to clarify that. And a solution could be saturated if it's holding the most that it can hold. Okay? So, like in the problem, it may say, what is the concentration of ions in this solution, or the solution is saturated, or a solution is made by mixing this many moles with this much water. Just a little clarification for you on those terms. Questions? Insert special character, and then you can draw an arrow, or you can type in arrow and it'll go. Okay. Now, our test is next week, Thursday. On Tuesday, we're going to do a lab that you're going to start on Tuesday, and then you will have to take your final observations and a final mass on Wednesday after you dry your sample overnight. Okay? And then after that, on Wednesday, we'll take any questions you have for the unit, give you some practice time, answer questions, because then the test will obviously be on Thursday. Okay? So keep it in mind, that's the way it'll go. And on Monday, we need to do what we call a bunch of pre-labbing, because you have to do some calculations ahead of time for the lab that we are going to do. In other words, I'm going to give you a reaction. You're going to predict how much precipitate you will create in your lab, and then you're going to go do that in the lab and see if you get that same amount of precipitate. Okay? So that is what we are doing. Now, dissociation is the splitting apart of an ionic compound in solution or in water. And the process only happens to aqueous compounds. Now, someone today sent me an email and said, Mr. Brand, on number 5 in the practice test, you use calcium carbonate, but it is a solid, so it's not aqueous in your reaction. And I'm like, all right, that was a good call, because sometimes I do mess that up. I put a formula where it doesn't actually work out. The problem is that person was sending that to me, and it wasn't a single replacement or a double replacement reaction. It was a decomposition reaction. And in a decomposition reaction, you could start with a solid substance and it can decompose. We look for precipitates in double replacement reactions to show that they actually happen. Now, here's what I'm telling you, ladies and gentlemen. Some of the reactions in the worksheet, I have written down no reaction because nothing happens. Not going to give you a 20-point problem on the test for you writing no reaction. Okay? Ain't happening. On the test, there is an 18, a 19, a 20, and a 19-point problem. Those are the 4 problems on the test. Okay? And then there is about I don't know, maybe 10 or 12 points of bonus problems on there. Okay? So again, you get an hour, you get the class period to do the test. If you're struggling on one of the problems, maybe go to the bonus questions because I don't care where you get points from as long as you get points. Questions? Okay. So for this next problem, we're going to assume 1 liter for all solutions because if it doesn't give us an amount, we can assume that there is 1 liter because as long as we assume the same amount for everything, we are fine. So sodium chloride is aqueous. What that means is that it will break apart into sodium ions and chlorine ions in water. Okay? Now, again, you can think of this as a mini balanced chemical equation. So for one of these, you get 1 sodium ion and 1 chlorine ion. Okay? So if we know that this is 2.25 molar solution, and we assume that it is 1 liter. Now, why am I assuming 1 liter? So that it's easy to get into moles. How many moles would it be if I assume 1 liter? 2.25. Molarity times volume equals moles, right? So if I assume 1 liter, okay, I get 2.25 moles of NaI. Correct? Okay. Well, let me ask you this. If this was in 1 liter, what are these in? No. They're still in that same amount of solution. All they have done is broken apart in the solution into the ions that make them up. So, what would be the molarity of the sodium ion? We take the 2.25 moles of sodium divided by 1 liter. Molarity is 2.25. The molarity did not change. Why? Because it's a 1-to-1 ratio. So all I have done is taken this, assumed 1 liter, multiplied them together to get to moles, used my ratio step, calculated the moles of sodium ion. Now if I want to find the concentration, I take that moles divided by how many liters of solution there are. Gives me 2.25. We do the same thing for the chlorine, ladies and gentlemen. What do we end up getting? Well, 1 liter times 2.25 moles of sodium chloride over 1 liter means 2.25 moles. Times a 1-to-1 ratio means I'm going to get 2.25 moles. Take it divided by 1 liter of solution because, again, when we put it into the solution, however much liquid it was in to begin with, that's how much it's still in. We get 2.25 molar solution of the chlorine ions. Because this is 1-to-1-to-1, the molarity doesn't change. The molarity doesn't change. So you can find the molarity of those ions in solution by simply breaking them up into the ions and seeing how many ions are created from the original amount. Questions? So, since this is 1-to-1-to-1, the moles are 1-to-1, makes our molarity the same throughout. Questions? Okay. And it all comes from these ratios, ladies and gentlemen. These ratios are important. Okay? All right. So what if we have a solution like this? Now, magnesium nitrate breaks apart into 1 magnesium ion. What's wrong? Last time I checked, magnesium was a +2. Sorry. Okay. And that's why there are 2 nitrate ions with it. We start out with 0.565 molar magnesium nitrate. Well, I just randomly picked that. Sophia, do you have a question?
Yeah.
Go.
I thought magnesium was a metal. How do I know if it's aqueous? Was that always in this?
Okay. If this compound is aqueous, what that means By definition, all aqueous compounds break apart into the ions that make them up in solution. That is what happens to them. Now, something else could happen. It could be a precipitate, in which case this would be a solid, in which case it doesn't break apart over here. Only aqueous ones do. Only aqueous ones do. Questions? Okay. So, we assume 1 liter. We take it times our molarity. Then we take it times the ratio, 1 to 1. We get the moles of magnesium ions. Those moles of magnesium ions would be in 1 liter of solution. So guess what? The molarity is 0.565. Same as it is here. Correct? Questions?
Is it always going to be how many moles it is?
Wait, what do you mean by that?
Well, the moles and the molarity are always the same. Is that going to be for everyone?
Because we're assuming 1 liter.
So anytime we assume 1 liter, it's always going to be like that?
Correct. Correct. Okay. Okay. So now for the nitrate, though. For the nitrate, though, look at our ratio. 2 nitrates to 1 magnesium nitrate. What does that do to our amount of moles?
It's different.
How? It's what?
Doubles.
It doubles. It doubles because now we get 2 of these ions for every 1 of these. Alexis, you're looking around like I did something that blew your mind.
No, I didn't.
Do you?
Yeah.
Okay, good. So now, when we find the molarity, since these ions double, guess what happens to the molarity? It doubles as well. It doubles as well. So, because the ratio in here is 1 to 1, the molarity is the same here. But when the ratio is 1 to 2, your molarity is going to double. Your molarity is going to double. What if it were 1 to 3?
It would triple.
It would triple. It would triple, ladies and gentlemen. Good. Questions? Okay. So now we have a compound, ladies and gentlemen, where it is 2 aluminums to 3 sulfates. So now you got a 2 over here and a 3 over here. What's going to happen to this molarity?
Double.
It's going to double. So again, when we go through this, volume times molarity times the molar ratio gives us 2.32 moles. Divided by 1 liter, it doubled. Went from 1.16 to 2.32. This one triples because 3 SO4s compared to 1 Al2 SO4 3. So the molarity triples. Okay? So again, ladies and gentlemen, some of these things will make life easier for you. Questions? Now, again, what would happen if this was a precipitate? None of this. It's not going to break apart. It's going to stay what it was. But I got news for you. You cannot find the molarity of a solid in solution. So you would not have a molarity for it to begin with. Questions? I haven't posted this yet, ladies and gentlemen, but this is the lab that you are going to do on Tuesday. This is the reaction that you are going to do. You're going to take a certain amount of sodium iodide and you are going to mix it with a certain amount of lead 2 nitrate. You are going to create sodium nitrate and lead iodide. That is what you are going to make. Now, when you make this stuff over here, it is going to all be in a solution. This will be a solid sitting at the bottom of your container. This will be ions that are floating around in solution. So if we look at it in terms of this, it breaks apart into these two things. You remember when I showed you this right before the first semester lab activity we did with the precipitates, where we had to predict what was in each bottle? Okay? And we talked about an overall ionic equation. And we said that there are some things in here that are just doing what? There are some things in here, ladies and gentlemen, that are just watching. They're not actually involved in the reaction. They're just there. Okay? Now, all of this stuff, though, will be in a beaker together. All of it. The problem is, I only want the what that is created in this reaction. The precipitate. I only want this solid. So in the lab, what you are going to have to do, ladies and gentlemen, is you are going to have to get rid of this stuff. But here's the good news. This stuff is in what form?
Aqueous.
Which means what?
It's dissolved in water.
It's dissolved in water. And how do we separate a solid from water?
You take it out
How?
because you see it. It's solid.
You're right. So, okay. Do you see the solid in here?
Yeah.
Here you go, take it out.
Well, this one you can't take it out, but you
Why
can
not?
see it.
This is going to be the same way your lab is going to be on Tuesday.
Well,
Your solid is going to be sitting down in the bottom,
well,
and you need to get it out of there.
you need to.
Well,
I guess you could
here's
just,
the
like, get
problem.
the water
Right
out.
now, what would be in this water? What? Hey, there's a good idea.
Oh yeah.
What did you say a little louder? Well, we can't technically use a strainer, but we can use filter paper. We're going to filter it.
Paper.
Why? Because the strainer, the sand would probably go through.
Yeah.
But the paper will catch this. Okay? Will catch this. But in this water right now, in your lab on Monday, what's in there still?
The little tiny one.
The ions. Still floating around in there. Do you think those ions have mass? Don't you dare say no to matter
Yes.
having no mass.
Yes.
Yes.
But they're just very, very tiny.
Right, but we still got mass from them, right? So if we're trying to figure out how much of this we created in grams, what do we got to do with this stuff? We got to get rid of it. We got to get rid of it. So what you're going to do is you're going to do a process called decanting. You're going to pour off the water that is on top to get rid of these ions that are in that water. And if any of that solid on the bottom happens to pour off when you do, guess what? There's a piece of filter paper there to catch it. To catch it. Any chance there's some water mixed in the bottom down here with this sand?
Mm-hmm.
So how do we get that out?
Put through the-
What?
put through the string.
Yeah, but if we put all that sand in the strainer, guess what?
The filter paper.
The filter paper is still going to do what?
That's all.
Nope, it's going to get plugged up. So what we're going to do is we're going to take and we're going to add some more water in here. After we get rid of this water, we're going to add a little bit more. Why? Because any ions that are caught in that sand in the bottom, guess what? They'll dissolve in the water you add. And now you can pour it off again. And then overnight, we've got a drying oven in the back. You're going to take the sample that is mostly just precipitate now. And the filter paper, you're going to throw them in together and you're going to dry it overnight. The next day you'll come in and you'll be able to figure out how much mass you collected in there. but you got to get rid of the stuff that's floating around in there. That's those ions that are in solution. They're a pain in the butt. But you got to get rid of them because otherwise they're going to add mass to your sample. Okay? And we're going to find out how good you do. And then on Monday, ladies and gentlemen, you'll get a card like this. And that card will tell you and your partner how much of each substance you are going to use. And then I got some cool lab equipment for you to try out, ladies and gentlemen. Ways to transfer solutions and things like that. But that'll be for Monday and Tuesday. Questions? Okay, good. Clear your desk. Uh-oh, spaghetti-o.
How many questions are on the quiz?
2.
Only 2?
2. One worth 14 points, one worth 7. Just 2.
Why 7?
Why not 7?
Are you playing with this?
Plus. There's a bonus point on here. Because I'm only going to grade it out of 20 and not 21. So you can mess something up and still get 100%.
I don't want to say.
Wow, thank you.
Maybe I'm not the right person.
Hey,
it's not
hey,
Mulder.
you have to tell me.
He's not shaking.
Thank you.
Polarity is
Like right now. You just like officially just said
good. Even though it's not polarity.
No, it's not. Grams over liters is not molarity. Absolutely not
So
molarity.
good. It's probably so expensive.
Can we work on
It's
this?
probably like $100.
As long as you do it individually, yes.
Oh, Alexis.
Like grilled cheese on toast.
No, there's no bonus
So,
question on this.
so it's okay. It is
No, I didn't say there was a bonus question.
Oh, it said bonus
I said there was a bonus point.
Oh, it's my name.
Thank you.
Hey, did you do those yourself? Did you do those yourself?
No carry on the table, nothing. You're
Yeah. I forgot about that.
Yep, I know everything.
I feel like I've never
Did you
went
see
that
your
way.
poster on the box?
These classes. I feel like I need to.
Dude, I sent a guy into one of those pages that blocked me. But what was how it blocked me? I'm guessing it was one of those.
So now I'm embarrassed. Oh, this girl said no.
Okay, so go into the number, like, what is it?
What?
For your mom. Oh my gosh.
It's the one that wanted to get away.
Okay. On the first page, ladies and gentlemen, you need to write a balanced chemical equation. You need to then take so many grams of magnesium and tell me what volume of gas would be produced under those conditions. Show all your work. Make sure that you list the states of matter. And also, ladies and gentlemen, that your final answer is in the correct sig figs with the correct unit. On the back side, ladies and gentlemen, you can thank me because I wrote you a balanced chemical equation. You just need to finish the problem from there.
That's like the worst part of it too, thank you.
Yeah, that'll be the last time I do that for you, by the way. So, good luck.
So many people.
On the front, make sure you show all your work. Balanced chemical equation. Final answer in sig figs and unit. The back, the equation is written for you. Pick it up from there. I can't tell you that, but I can tell you all acids begin with hydrogen.